when x is equal to 2, what would u equal? Well, u would equal 2 times 2 plus 1, which equals 5. And then when x is equal to 1, u would equal 2 times 1 plus 1, which is equal to 3. So now I have my two variables in terms of u. I can start integrating. So I've got 5, I've got 3. When I start integrating, I've got half du. So I can do half times u to the power of 4 du. Alrighty, let's now start integrating. So we get half times u to the power of 5 over 5, and that will be all to the power of, that will be raised to the power of 5 and 3. Let's simplify this up. This here will be the same as 110 u to the power of 5, 5 and 3. So we get 1 over 10, replace the u with 5, minus 1 over 10, replace the u with 3, and we get our answers. Oh, I didn't bring my calculator with me. Let's see if I can do it. So we've got 625, so we'll say 625 over 2 minus 243 over 10. 5, yep. And that gives us 1,441 over 5. So when we're looking at this question here, we're doing exactly the same kind of thing when we are mixing definite integrals, but we're using the idea of substitution. So this here you could probably do in using the normal integral rules, but we can use it with substitution as well. Again, using that same process, finding u, differentiating u, manipulating it if possible. However, the extra step here is finding these parameters in terms of u now instead of x, because we're integrating in terms of u. And once we get to that point, we just treat it like it's a normal definite integral. Substitution, very, very useful to have. It can, if you can't integrate something, the chances are you could integrate it using substitution. So let's substitute something out and integrate it a different way. We follow the 5 different steps. We pick a u expression. What's going to represent our u? And then think about what we said right at the start. There are different types of things. Think about those chain rule kind of questions. Inside the brackets is a u. Over the denominator of a fraction is generally a u. A square root is generally a u. Exponential, generally a u. We then find, once we find out u, we find our derivative. If we can substitute both the u and the derivative u into the equation, fantastic, happy days, we don't go any further. However, if we're not able to do it, we manipulate it so it can fit into it. Once we've got it in terms of u, we integrate in terms of u and du, and then once you get to the end, you just replace what your u expression is back into, if this is for the indefinite integral, back into the equation. If it's for the definite integral, we don't even worry about that last part because we've used our values in here and changed in terms of u where it was x. Alright. Substitution, integration, lots and lots of fun. Enjoy.